I'm going to go ahead and get started. It's always a little strange to hear my voice over loudspeakers all of a sudden. So I'm Chris White. I'm a senior program manager on the Kinect for Windows team. And I'm actually super, super excited about the talk that I get to give today. Basically, all of the cool toys that exist that I always wished I could play with, those are the things that I get to talk about and show a bunch about today. So kind of like a kid in a candy shop. So we have kind of three major areas that we will talk about. The first one is 3D printing. There were some awesome announcements over the last course of the last couple days. There's obviously some interesting tie-ins with Kinect, and so we're going to work through some of that. We're going to talk a little bit about Kinect Fusion. We kind of did our initial reveal of it at Build last time, so we're excited to be able to come back, talk about some of the future stuff. Then we're going to talk a little bit more broadly about some of the Kinect future. So what are the things that will be coming over the course of the next few months, over the course of the next year. It seemed like a lot of people were here during Tech Check, so some of you probably saw little hints at what's coming. So first, we're going to take a look at 3D printing. So I really like to think about this. This is sort of a story of partnerships, things that go really, really well together when you think about them. So first of all, Windows and 3D printing. You know, we announced that this was going to happen. We think there's a really, really interesting role for Windows to play in terms of sort of bringing the whole story together and making it work for consumers in a broad way. As part of that, obviously, we're going to work with people across the industry. So once again, you know, super happy to be working with all of these partners on sort of both the outputs, so the people who are building these awesome devices that are actually printing things, and then also on the people who are working on software to work with the data along the way. And then obviously the next one, and the one why we were talking about it, is we think that Kinect plus 3D printing is super important. One of the things that's hard is actually model acquisition. So where do you actually get the files that you're going to drive through the print pipeline? Kinect as an acquisition device is something we're all really excited about. So I said up front that we're going to do a lot of demos. I'm going to try to spend most of my time today in demos. So we're going to jump into the first one now. So Ben will be my demo monkey today. So anyone who wants to make fun of him, it's strongly encouraged. Let's jump over. So what we're seeing here is an application that was thrown together actually really, really quickly. But it's an app using Kinect to get 3D geometry of the person or thing that it's staring at and then create a printable model out of it. So Ben's really stoic. I kind of wish I could freeze you in Carbonite, so let's see the Han Solo pose. Okay, so we're going to go ahead and save. And we're going to say Ben, carbs. All right, now that's going off and saving. Now I'm going to bring up, if we were writing this as an app that we were going to release, we would set it up so that that could just go straight to printing. I want to show a little bit more of the story about how you can go end-to-end with different apps working together. So I'm going to show an app from Autodesk, which is plugged into this 3D print pipeline as well. And we're going to pull Ben. So this is one I did of Ben a few minutes ago. It's already loaded in. But this, we can see, is actually Ben in Carbonite. And we've set it up so that it's scaled it out a little bit, did some modifications, set it up so it would be easy to print, least support material. We're going to go ahead and just press print. And at this point, we've sent the job to the 3D Systems printer, which is over here. So in a couple minutes, it's going to start moving. It does actually take it a few minutes to figure out all of the pieces of how to slice it, how to send the instructions over to the printer. But in a couple minutes, it will be active. So Ben, step off. Thank you.
Thank you.
All right, so real quick, we saw capture with Kinect. We wrote out to a 3D file, so to a mesh. We saw it opened up and processed with an Autodesk application, so it was able to pick up any 3D file. We're seeing it start to wake up now. We're seeing the last piece of the demo light up. And then we used just the print function in Windows to go ahead and send it across to the printer. And then the printer is now starting to warm up, and we're going to get a little copy of Ben in Carbonite in a minute. So roughly what that looks like, went back, but what that looks like are these little guys. Do people want 3D prints of something? He does. Somebody else? There will be some more. We'll be doing these at the, want bigger items? That's a terrible throw. I'm going to stop because I'm going to hurt somebody, but there are some more up here, and we will give them out at the end. We'll also be doing 3D printing at our booth tomorrow, and there's a bunch more going on at the booth right next to us. So these small trinkets we can generally do. And whoever asked the best question can get the copy of Ben that we print right now. So we'll do that towards the end. Now, the thing that I like about this that I think is really cool is we saw these 3 different pieces, and they were able to be built totally independently, but because of the work that we've done in Windows, these things tie together seamlessly. So that Autodesk app is going to work with any 3D printer that you plug in. The 3D printer is going to work with any app that's built to output stuff. So we think there's real value there. All right, so talk a little bit about Kinect Fusion. I realize I don't have in my slides a big overview of what Fusion is. We are going to see a demo in a moment. I'm assuming a lot of people either saw our talks at Build last year or have seen some of the press around this. So high level, it's a real-time 3D scanning application. Think about what we just saw, but kind of on steroids, giving you high-resolution models. So we announced at Build about 8 months ago. We unleashed it on the world. We released the SDK about 3 months ago. We saw scanning and 3D printing just a moment ago, and there's more stuff coming soon. So we're going to see some of that as well, and we're excited to show it. So in the not too distant future, let's jump over. Now we have to close some apps. 1 second here. All right, so Ben, could you come on up here again? So for people who've seen Fusion or have not seen Fusion before, we're going to see the beginnings of a reconstruction forming. But the picture that we're seeing is obviously not in real color, right? Like this is a relatively it doesn't look a lot like Ben. Like you can see the structure of his face, but you can't actually see his skin and stuff. And so while we can see the geometry, it's not everything that you would want from a full 3D model. But we're now actually capturing color as well. And this is a very low resolution one, but you can see the massive jump in realism that happens when you have a model that is captured like this. So I'm going to jump out. And so we could easily there, you're good, Ben. We could easily there save that out to a 3D mesh and then do something like load it back into that Autodesk application, do other interesting digital things with it. Sweet. So let's go back to 1. OK, so we're going to jump and talk a little bit about Kinect Futures. So I think this is one of the things that people are really excited about. This is obviously one of the things that we're really excited about. Now, the first thing I'll call out, and I think it's actually super important, is whenever we talk about Kinect Future, it starts actually with our current sensor. We think that there's a ton of stuff that it is great at. There is an awesome amount of innovation that has happened against it. So people have built and deployed solutions. And we want to continue supporting those solutions. We want to help people continue to scale those solutions. So in addition, it is great at many things. If you're building something around digital signage, as an example, no reason to not go build on this today and execute that solution. And the other piece is we have a large continued software investment in it. This is something we really believe in. We saw a bunch of stuff in Ben's talk earlier today about combination of HTML and JavaScript. We saw the green screening stuff. We also just now saw sort of a sneak peek at some of the advancements that are coming in Fusion. There's a lot more that will actually be happening there. And so we are announcing our 1.8 SDK will be coming in September. These are the list of features that we've talked about and demoed at Build. There is a longer list of things that will be coming in this, but we're not talking about those things today. But high level, we're continuing to bet on it. We think it's awesome. We think people should still build apps on it, and it does have a place, even in the face of new tech which is coming. So obviously, we're all super, super excited about what's coming with the next generation sensor. And really, everything gets so much better. It's basically, think about everything snapping into HD. So we're going to do a demo. Ben, if you could come up. OK. So quick note, we are doing a demo today on the Xbox. The same core of the tech is going to be the same core of the Windows tech, so this will give a really good walkthrough of the capabilities which are going to be there. But I don't want anybody to walk away from this thinking, hey, it's already on Windows and we can give it to you tomorrow. This is early hardware running the whole stack. So the first thing I will call out is if you look your attention up on the screen. I know you want to look at Ben, but look up at the screen. You'll see that we actually have much more information. Now first, before we even go into like how much better it looks, I want to call out this is a depth image. So it's often easy to look at the image and not really understand what's happening, but here we understand how far away every single pixel is that we can see, and we can see at a very fine-grained detail how far away each of those things are. So you'll notice, first of all, the picture actually looks like Ben. So for those of you who've been working with Kinect for a while, you get a blob. We can identify that it's a person. That lets you do awesome things. But now the thing that's up on the screen is just as funny looking as he is. So you can see all of the detail around his face. You can see his ears sticking out. Let's go head side to side. See, open the mouth and see your tongue. You can see the details around the eyes. See going down even further, see him going side to side. We can see the individual little ripples coming out in his shirt. So there's all kinds of stuff that you can do when you get this much higher degree level of fidelity in the data that you're seeing. The other thing that you'll notice, look at his fingers. Look at how well detailed those are. Even as he comes in close to his chest, you can actually still see them and identify them. On the old sensor, that would actually disappear below the noise floor, and it would sort of merge into his chest. So we're going to jump forward. Actually, before we jump forward, come closer. So we can actually get quite close. You can even get closer. So now he got a little too close, but as he's very close, you can still see large portions of his body. So we have a much wider field of view. Now, normally, when you get to a wider field of view, there's this inherent trade-off. Although, because you see more, each and every pixel that you're seeing is actually conveying significantly less information. What we've done here is actually widen the field of view, but also sharpened the resolution so that every single pixel is now conveying 3 times more information. So we have 3 times the fidelity and much more data. I'm going to have you walk back towards the edge of the play space. All right, we're going to have him leave. Oh, he can't even leave staying on the stage. So we can see far enough back. So keep going. Keep going. And stop. So take one more step forward. So quite a long distance that we're able to see. And now as he walks that way, keep walking and come a little closer. So you can see nice broad range field of view sneaking in from the side. So we can see much better in this sort of weird depth thing that we're not used to thinking about. We can also see much better in color. So this is full 1080p color. Now if you want to do interesting video things, you're able to actually see what's going on much better. And it is a nice, beautiful widescreen, so it's, again, that wide field of view, so you get lots and lots and lots of information. Color is awesome, but one of the things that you guys know you want to do with something like Kinect is the sensor is interesting computer vision stuff. So it turns out that, well, color is great for doing pictures, and it's great for conveying a sense of who it is, building tchotchkes. Like, it's really hard to teach a computer to understand what's going on in that color signal. It's because you do things like put a lamp on one side or the other, and it's going to change how he actually looks. So first of all, we can see in the dark. Second, it's completely independent of the lighting. So can we actually bring the lights down for a second? I'm going to go back. As far down as you can go. Nobody move. It's going to be terrifying.
This is the horror session.
Yeah, so notice from a color perspective, he now has that lit from below look, which is terrifying. He's telling stories in the dark. But from the IR perspective, this active IR stream that we have, it's completely unchanged. So we're able to do all of the interesting computer vision stuff against the active IR stream, and we have this nice, beautiful, stable signal, which is possible to do much more sophisticated stuff on. Let's bring lights back up. So far we've kind of focused on the eyes of the sensor. The next piece we're going to talk about is ears. So certainly within Xbox, one of the things you want to be able to do is issue voice commands in noisy environments. You know, your volume is up, there are grunts throwing grenades, there are explosions. You want to also do a lot of these things in Kinect for Windows examples. I'm going to play a clip of Halo, which is the way it's actually recorded from one microphone. So what the system hears before it applies any of the intelligence. And you can kind of hear what somebody says if you listen really carefully. All right, so now we're going to hear exactly the same thing, but heard after all of the processing it does.
Delta Squad, move left. Delta Squad, take cover. Mortar cover, on my right. Rally to checkpoint Bravo.
All right, so high level, we're able to separate out the noise that is being generated from the system very, very strongly from the noise which is generated from the person. We have other advancements in terms of being able to separate noise coming from specific directions, forming very, very tight beams pointing in certain directions. So we're really, really excited about a lot of that coming to Windows. So we've talked a bunch now about eyes and ears, and this is kind of the initial senses of the Xbox, the basic inputs that it has, and they'll be the basic senses that the Kinect for Windows sensor has as well. But a lot of the interesting stuff is obviously up in the brains. It's after the senses. So the first thing that we're going to see is skeleton. So take a quick step back, Ben. So here we see a nice, beautiful, stable skeleton. So for those of you who've worked with the Xbox, with the original Kinect for Windows sensor, you'll notice some significant differences. The first one is the skeleton is shaped differently. So as an example, his hips are actually where his hips are. The base of his spine is actually where the base of his spine is. Second, you'll notice that it's a much more stable signal. So instead of being this really jumpy, noisy analog signal, it's a much more stable signal. We've also added a bunch of joints. So in addition to being more correct for the ones that are there, we have more. The first one is, you'll notice that we have something here. So do shrugs. So all of that additional high fidelity data that we're getting allows us to see all of these tiny motions. He can do the little wave with his shoulders, actually see all of that coming down. So if you want to build a dance recognizer, this is a great tool. And doing swaying side to side. So you actually get much more information, much more subtle data. Now, for the people who are paying close attention, you probably notice that there's something different about his hands, too. So we've added 2 joints in each hand, 2 extra joints, one up at the end of the hand and one at the thumb. So that lets us actually see and understand kind of what the hand is doing in a much better way than just the single point that we had before. And we think this addresses sort of most of what you want to try to do with hands. So what we've been seeing so far is kind of where are the joints, how are they put together, what are the lengths of the bones. But there are lots of cases where you want to understand things about the orientation as well. And we've done some joint orientation stuff in the Kinect for Windows SDK before, but there were lots of cases where you just didn't have enough information to get to how is the lower arm really oriented. So now we actually are able to do all of that and pull it together so it's easy to consume. So this is a guy that we call Boxman. So first, as Ben's moving his head around, you'll see that the box on the head is tracking. And then as moving the arms and shoulders, and so you can actually see as his arm turns, it's correctly tracking what his hand and arm are really doing. And down you can see even popping out the gloves doing the Captain Morgan stance. So we could build recognizers for that as well, and it would be easy. Cool, so I think that's the pause of what we're going to do for this guy. That's not the thing that we're controlling. So I'm going to walk back over no, you're good. Back over the things that we saw. So first of all, we saw the eyes and ears. So we saw 3 times the fidelity on depth. And you really got to see how that pulls more information out and talked about why that matters. So significantly wider and taller field of view. So we're just able to see much more of the world with each sensor. Much better color stream. So this is kind of what you're going to expect today, is this nice full 1080p color. And then awesome improvements in audio. And then the brains of the thing also got much better. We have the more accurate skeleton joints. Hands, which are going to be super important, and we're excited about those guys. Again, better audio, and then we saw the active IR, which lets us see in the dark. Now, one thing that I didn't talk about, and towards the end, we'll actually let some people come up and play with this. It used to be that we could see where 6 people were, but we only put skeletons in 2. So everything that we're talking about, we're able to do for all 6 players in the playing space at the same time. So we're quite excited about that. And when you take, it can see, it can hear, it can think, and it's this beautiful little device. There are tons of things that you can do with it. So, a quick summary of those are digital signage, physical therapy, and fitness. We think get way, way better because you can actually, first of all, seeing where the hip really is. Turns out it really matters if you're doing physical therapy for your hip. ST being better is going to help with fitness in a ton of different ways, particularly as we get broader for the range of poses and situations where we track correctly. If you think about trying to train somebody to do some kind of mechanical process or understand and watch as they're doing it, getting to this fine-grained understanding of how they're using their hands, how their whole body is oriented, it's actually going to be really important. And obviously, since we have higher fidelity data coming in, we have much better cameras, all of the communication and collaboration stuff that you're going to do is going to be able to just get much, much better. So a quick recap, and then we'll jump into questions, and we'll let some people come up and dance for the Kinect. So first of all, 3D printing. We saw this end-to-end experience, which actually is now done. So the piece that we started at the beginning where we scanned somebody, it has now come out the other end, and we have a tiny little copy of Ben. And there were these 3 different components that totally different people made that all work together and work together seamlessly to make this kind of thing possible. So it's easy as a developer to think about plugging something in to any one of those spots. We're super, super excited to see what, particularly this community, what the developers come up with and what they build here. Again, I'm like a kid in a candy shop about this stuff. I'm not going to throw this yet. Second, we saw some of the Kinect Fusion stuff. So the 3D scanning, we saw the addition of color there. We're very excited about that, and we're excited to talk through some of the 1.8 features. We are continuing to invest in the software for the current generation Kinect, and we talked a little bit about the next generation, which is going to be coming next year. If people saw the announcement yesterday or saw Ben's talk earlier, they'll know that there is a dev kit program in November. And we're looking forward to see applications. Here are resources. This stuff is also all up on the Kinect for Windows site. So we're looking forward to hear what people want to build with the new tech. So I think we'll do 2 things. We'll jump to questions, but then, Ben, could you round up some set of people to come be able to play around on the stage?
Nobody? Yeah, back there. Anyone else? I need like 6 people total. Yeah, you right here. Over there. Yeah, right here. Right there. Is that 6? So go ahead and get up there.
Yeah.
Okay, could you bring up some dubstep, please? I'm just kidding. I'm kidding.
All right, break the algorithms.
Yeah. So as we're doing this, people can definitely have fun, cycle through. And if anybody can concentrate at the same time that's going on, I would love to take questions. Should only take
Could you
about a frame or
use
two.
one of the mics in the aisle, please? Thanks.
Yep.
Question: when you did the audio, the audio cleanup sample.
Yep.
Was that just processing the microphone feed, or were you taking advantage of the fact you knew what the game's audio was?
It is definitely taking advantage of the fact that you know what the game's audio is. It is a combination of both things. Obviously, if you know what the sound is, you can do a much, much better job of canceling it. The new gen Xbox does, the first one did an amazing job, the new one does a much better job. And we're looking forward to a lot of that tech coming to Windows as well. We've also made significant improvements in things like the beamforming that controls kind of the cone of sound that you're hearing, and noise suppression, which is tracking other random sounds in the environment, actively canceling them out. So certainly what we taught, like that level of difference, if you have no idea what the original sound is, it's going to be super hard. But the envelope where speech will work is going to get better. And that's both because there are better microphones in the device and because of advancements we've made in the software.
During the E3 demos, they were talking about they had heart monitors and.
Yep. Yeah, so great question. We actually have those demos. The short answer is we want to stay very, very focused on the things that were going to be available for devs really soon. So there was a lot of stuff in E3 which it's all real, absolutely, but will not be in the Kinect for Windows SDK right away. Certainly not in the alpha that we have in November. And so we think there's a ton of exciting stuff in what we've already shown, and didn't want to get people too excited about that stuff. We're super excited about it. It will come at some point, but it's a little further down the road.
Okay, thank you.
Let's go that way.
Okay, traditionally when you're doing 3D printing with the older printers, there's a piece called Replicator G that translates the STL file to a toolpath. In this new system of integration you guys are doing, where does that conversion sit?
Chris? I can follow up with them afterwards. Okay, we have an answer. We will follow up after. Just come up at the end.
Okay, sounds good.
So before the Kinect SDK came out,
Yep.
I'm sure you know that Kinect was basically kind of, I guess the software was taken apart by people using open frameworks and all these other things.
Yep.
Is the hardware any more locked down than it currently is? Is the new hardware? Is it going to be more difficult for... Are you allowed to talk about these things?
Man, I'm going to get myself in trouble.
I guess basically, can someone using open frameworks still do the same things they do now?
Yeah, so at a high level, the question is, could a hacker go and play with the device? We are actually not doing anything to try to prevent that. We're doing less than we were before. Now, there's much more complicated processing that's going on the computer as compared to the device.
Yeah, sure.
So some of it's going to be hard, but it is hard because it's an intrinsically hard problem, not because we've put roadblocks there.
Sure.
But can I just tack onto that?
Sure.
We actually want people like that to apply for our dev kit program
Yeah.
that's going to be in November, because we are serious about just enabling all that creativity and all the crazy ideas that people have.
Yeah, day one, we would love it if people come in, hook up open frameworks to the SDK, which we have, so that they don't need to go solve those hard problems. We want to make it super, super easy for people to build things.
So, two questions, both are pretty quick.
2 questions.
Yeah. The first one is, are we going to see finger models? I mean, finger mode or something, like hand fingers? The second question is, on the devs image, I saw a few, it looked like dead pixels. Is that like a production pre-sample variation, or is that by design?
So 2 questions. First one, let's do dead pixels. It is certainly a pre-production device. It's one of our early builds of hardware. It's been carried around the country a couple of times
so
to E3.
It does not have dead spots or something like that?
Yeah, it shouldn't. I don't believe that's an issue with the normal devices. I think this one's been kind of beat to hell. I'll probably get in trouble when I return it. If I return it, I kind of want to keep it. Okay, and then the second question was about hand models and finger models, and the answer is, I'm sure, of course, we will. If you look even against the current sensor. There was a bunch of work done last year at CVPR that had full hand models, so full articulated skeleton processing models that were basically re-implementing the forest fire algorithms that MSR built that was behind the original ST, and then applying it to hands. So it was a bunch of students, they did it, it was awesome. Works when your hands are reasonably close to the Kinect. We have much more fidelity, so people did it against the old one, we can see better. Of course people will do it now. We're not announcing that we're doing it, we may at some point.
All right, thanks.
If you have multiple cameras that overlap, will they cause interference like the current Kinect does?
So we've done some testing about it, and the short answer is marginal interference, but most of the time it's almost certainly fine. The camera in this is actually taking these tiny, tiny, super fast photos, so the chances of them really overlapping perfectly where the signal from one is going to screw with the other one is quite low. So the effects are going to be kind of the effects of increasing the ambient illumination by the amount of light that we're piping out into the room. There are theoretical cases that you could hit that could go badly, but on average, when we've tested two of them together, no issues. Also, and totally fun thing is that because they use different tech, the two of them don't interfere with each other at all. So you can point one of these and one of these at the same place and no issues. Get to be box fan now. Yeah, go on.
What kind of delay is there on the audio filtering?
Not a lot. No, I mean it's we do processing in 16 millisecond jumps, and then there are a series of stages it goes through. So you're talking on the scale of 60, 70, 80 milliseconds, which think about below 200 don't matter for communication situations. You probably wouldn't want to build music feedback that's going right back to the musician's ear. But for normal voice situations, it's below the threshold where people pick it up and perceive it.
Any plans for multiple sensors to have like two in a room?
So that's something that we support with Kinect today, and fully expect that we will support going forward. That's why we did some of the other testing. Whether that happens on day one of the SDK availability, probably not during alpha. Probably at day one, not definitely, but definitely at some point. Silence, a deep booming silence echoes across the room. All right, well, I think I'm the last thing between you guys and drinking, or partying, or doing whatever it is that you do. So I'm happy to stay up here and answer questions. People should feel free to come up and we can chat, but feel free to be released as well.